Hi, I'm Philip Crisp.
And I'm Eva Crisp.
Together, we'll show you how to get started with RiskAssess.
RiskAssess lets you quickly and easily carry out a risk assessment of any experiment. Provides you with background information on the hazards of chemicals, equipment, and biologicals. It also includes a lab scheduling system, plus you can create all sorts of chemical labels. And it is very easy to use.
To start, I go to the RiskAssess website and log in. I've done that step already, and now we're on the home page. Let us click on Start Blank Risk Assessment. I enter the author, Philip Crisp. Let us suppose we're going to make hydrogen using magnesium ribbon and dilute hydrochloric acid in a test tube. The experiment name is Making Hydrogen. And the text reference is SB, page 44. Or you can copy and paste a whole procedure from somewhere else.
And don't forget that you can hot link to documents from the web or your school intranet for SDSs, procedures, diagrams, etc. by entering the web or intranet address in this box.
The teacher now is Philip Crisp. And the year group is 10 Chemistry from the drop-down menu. Chemical training codes are optional but recommended.
You can click the link for an explanation. Note that wherever you see a link like this in blue text, you can click it for more information.
Now the scheduling is room 103. Period 2, and the date is the 2nd of October. Only enter multiple dates if you have an experiment that runs for several days, like growing seeds and watching how they progress over multiple lessons. You can add scheduling notes to help the lab tech if you wish, and here you can detail the items to be prepared by the lab tech. Let's put in 6 groups of 100 ml 3 molar hydrochloric acid. And so on. Now we come to the items used in the experiment whose risks have to be assessed. I'll just add a few examples. We'll need a test tube. The pop-out box allows you to choose test tubes. Let's choose a medium test tube. Some magnesium is next. We can enter just a partial name. MAGN is sufficient. The dots offer choices for magnesium metal. Let's choose magnesium ribbon. And some hydrochloric acid. I enter HCl and choose a concentration range 3 to 8 molar. And the chemical produced is hydrogen, which we can enter as H2. Hydrogen generated during the experiment.
It is important to enter chemicals produced because a flammable gas or a toxic chemical might be created during the experiment.
Now we click Generate Risk Assessment. This is the risk assessment form that I now need to complete. I can see the background information on test tube, a magnesium ribbon, dilute hydrochloric acid, and hydrogen gas. Beware of damaged test tubes. Dilute hydrochloric acid is an irritant. Burning magnesium ribbon emits ultraviolet radiation, which can cause eye damage, but we are not burning magnesium in this experiment. And do not generate hydrogen in a closed container, since the container may explode.
Yes, that is a very important message. Many injuries have occurred as a result of generating gases in closed containers.
Now for the actual risk assessment. I need to agree that I've read the safety information and have copies of SDSs available. For the risk assessment, I need to consider carefully the possible risks in the list, from fire, explosion, through to allergies and special needs. Next, the certification by teacher. The teacher has to assess the risks associated with carrying out the experiment in the class and has to control the risks. To start with, the teacher assesses the inherent risk level of the activity, that is, without control measures other than the routine procedures in the laboratory, like not running, hair tied back, and wearing safety glasses whenever experimental work is going on. I estimate the risk level to be medium for this experiment. A box now opens and the teacher can enter control measures. The idea is to introduce enough control measures that the risk level for the experiment with the control measures in place is reduced to low risk. If the inherent risk level is high or extreme, a third person, an authorized person, is required to check the risk level and certify that there are sufficient control measures to reduce the risk level to low risk. I need to enter control measures. Point test tube away, and so on. Some of the common control measures are shown at the bottom. I can also click on safety glasses. I save the control measures. Finally, I sign electronically. Philip Crisp.
Signing electronically is legally the equivalent of signing a paper copy.
Now the lab tech has to assess the risks associated with preparing and, if necessary, cleaning up after the experiment, then control the risks associated with those activities. The inherent risk level for the lab tech is low risk for this experiment. Note that no box appears for control measures since it is already low risk. The lab tech signs. Once there are the required number of electronic signatures, 2 in this case, or 3 if the risk level is high or extreme, a PDF file is automatically generated by RiskAssess. It can't be edited and serves as a legal record that the risk assessment was performed as required by law. So here is the completed risk assessment for the experiment. Details of the risk assessment show up on the scheduling page, which we will show you later. I click the banner to go back to the home page. Remember that you can use this trick at any time to go back to the home page.
Now, suppose Philip told me about his great experiment, and I want to do a similar experiment with my class. First of all, I have to find the risk assessment and make a modifiable copy as a starting point for my assessment. I can either look in the recent risk assessments or do a risk assessment search. I'll do a search on hydrogen in the experiment name. Note the filing cabinet icon. This means that the risk assessment has been archived and cannot be changed, thus providing a legal record in case anything goes wrong. Click Making Hydrogen to open the risk assessment. I'll click Create Modifiable Copy so that I can customize the risk assessment for my class. I enter my name as the teacher, Eva Crisp. I have a different grade, a younger class, 9. The scheduling is room 214, period 4, on the 4th of October. I generate the risk assessment form as the starting point for a new risk assessment. I might decide my class is younger and not very well behaved, so I'll make the experiment a demonstration. I update the control measures, click demonstration and save the control measures. The lab tech just told me that we have run out of magnesium ribbon, so we'll use zinc granules instead. I'll use author's update to change the chemical used. I remove the magnesium ribbon and put in zinc. Click on the dots and I'll choose zinc granules. Note that author's update is only used for editing a risk assessment to make updates and improvements. For an experiment on a different day with a different class, with a different teacher, or in a different location, use create modifiable copy as we did earlier. That way, a legal record is kept for each risk assessment. Later, I will update the risk assessment and will complete the risk assessment by checking the control measures and signing electronically. Now I'll look at the laboratory scheduling. I've gone back to the home page. This is the laboratory scheduling is the calendar that lab techs and teachers use all the time. I can see risk assessments of experiments for today, tomorrow, this week, 4 weeks, or for any dates. I'll click on the next 4 weeks. The lab techs can tick the prepared box as they work through the preparations, and they can write any additional notes as needed with the Add Prep note. I'll insert running out of magnesium ribbon. I can see the lodgement date beneath the experiment details. The school may choose to have a cut-off time for lodging pracs. Although not part of the risk assessment process, the scheduling system will save you a lot of time and help you to organise things. So we'll go back to the home page.
Now, suppose that I'm a lab tech and I need to label some bottles of chemicals that the students will use. RiskAssess gives you a particularly simple way to create labels according to GHS, not only for pure substances, but also for more than 1,000 concentration ranges of aqueous solutions. Click Print Labels. I have the choice of standard labeling or custom labeling. Standard labeling creates labels using data in the chemical database and is suitable for nearly all school chemicals. Custom labeling allows any chemical label to be created for mixtures, commercial products, and so on. I'll choose standard labeling. I want to make some large labels for 12 molar hydrochloric acid. I type HCl and click on hydrochloric acid solution. The concentration I want is 12 molar. I have a choice of 4 sizes of labels. I choose the large labels. I'll print borders and a full page. I download the labels and it takes 30 seconds or less to create a page of labels. Finally, let's look at the learning resources. First of all, there is my 250-page book on safety in schools as an ebook. Just click on it to find it on your home page. The book is licensed for unlimited use within the school. Then we have a range of learning resources. Just click on the footnote, and we also have a questions and answers to help you. I've only been able to give a summary of the key features. There is much more to RiskAssess.
I hope you found this useful. Have fun with RiskAssess.